Okay, so I want to see what you can remember from what I did on the last video. And if you can turn this off and get it right, then just turn it off, fast forward through it, and see if you get the right answer. So let's go to what we do know. When sine of x is equal to 0, cosine would be undefined. And I think I forgot something in your notes. Undefined. Let me scoot this slightly back up. There, that's what we needed. Let's go back and get this filled in. Yeah, I want that one. Okay, so this means, hold on, go away. There we go. Cosecant x is this inverse of sine of x. So we're going to graph the y-coordinate of cosecant x is the inverse, the reciprocal. I should say the reciprocal. Let's erase that and say the reciprocal of the y-coordinate. So let's go back. Reciprocal. There we go. Okay, so it's undefined because if you put, this is y, you put 0 over 1, you flip it and get the reciprocal, you get 0, 1 over 0. Dag nabbit. Okay, it's the end of the day and I'm trying to get this made. My apologies. 1 over 0, which is undefined. So the period is still 2 pi. The domain is going to be almost all real numbers, with the exception x is not equal to, okay, so we need to look and see where these asymptotes are. And this asymptote's missing because of the axis falling on top of it, your y-axis. So notice these are increments of pi. So k times pi. That's our domain on this. The range is going to be, okay, notice I just went over it and you can't see it anymore, but this said -1 right there. So the height of this, remember the sine graph goes to positive and -1. So it's going to be negative infinity up to -1. Now this matches the other range. Union with 1 to infinity. Okay? Oh, and let's fix this. It's including the 1 and the -1, so those should be brackets. Okay? Brackets here, parentheses on infinities because there's no top to infinity. All right? Vertical asymptotes are at every k pi. It's x equals k times pi. And if it makes you better to say h times pi, you can. I don't care. You can pick n times pi if you like. The symmetry is not around the y-axis. It is over the origin. I'm not going to put a lot of weight on that. Origin. That makes it, ooh, how do I know it's symmetric about the origin? Because look, this sine function is going through the origin, so it's doing a rotation around. That's why it's symmetric over the origin. That makes sine an odd function and cosine an even function, FYI, just in case you want to know. All right, so we're going to roll this up, and we're going to see if we can graph this. Okay, so we're going to change to y equals 2 sine of x minus 1. 2 sine x minus 1. So a is 2, b is 1, the period is 2 pi, c is equal to 0, yay, and we are not going to have any phase shifts. I'm just pulling those out because I don't want to mess with them. We need to hurry and get through this before the break. So I'm helping you out. Y equals -1. Guys, a lot of you have forgotten about that on the quiz. You've got to have your y equals -1. So my amplitude is 2. So if I do, I'm looking at where I want to put -1. If I have to have an amplitude of 2, 1, 2, This is going to be the top of my amplitude. So I'm going to have an amplitude line right there. Okay? And so 1, 2, amplitude line right here. That's helpful. All right, now I'm going to go in and I'm going to label, I'm 0 to 2 pi. So let's get all the help. Let's treat these just like I'm doing sine. So this would be pi, pi over 2, 3 pi over 2. Sine goes from 0, 0, 0, 1, 1, and the second one's negative. And then I'm doing 2 times asterisk minus 1. So that's going to be negative 1 on all the zeros. 1 times 2 is 2. 2 minus 1 is 1. Negative 1 times 2 is negative 2. Minus 1 is negative 3. Okay, so if I go to graph this, I need this to be, I need increments of pi over 2. So I've already got pi, so I'm going to keep that. This is pi over 2. This is 3 pi over 2, and this would be about 2 pi. Now I could keep this going, but I'm going to go back the other way. Negative pi over 2 pi, and it is negative pi, and negative 3 pi over 2, and negative 2 pi. Now, we could talk about this all day long, but I'm going to go ahead and graph. Oh, I did not put in my midline. Yikes. Let's put my midline in. I'll make it blue. Midline is going to be, what is my D? Negative 1. It's right here. Look at that going through all of my numbers. How rude. Right? Rude. Okay, not a very straight line. Graph paper is much nicer to us. Okay, in yellow, I'm going to graph. I'm starting at negative 1. I'm doing sine. Starting with sine, it is positive. So I will go up to the top of my amplitude, down, down, back up. It would be up, up, but, okay, rainbow. I'm not going to keep it going. Bowl. Rainbow, and it keeps going. This goes down the bowl, up to rain. I think I just messed up. I am trying to do this. Dagnabbit. Well, it was crooked anyway. I'm trying to do this without my points, and it's going to get me in trouble. Down, up, up, down. There we go. Now I can do my bowls and rainbows again. Okay, so this is what I wanted. Now what I'm going to do is put my amplitudes, my asymptotes in, and they're hitting everywhere this hits. Here, I'm going to do it just like I did on the first one. I love the yellow and red, even though it is McDonald's. That's not my favorite place to eat. And oh my gosh, so I totally missed this one. Boy, that was a sad, pathetic one. This one is right on the line. This one is here. This one is here. So the only really bad one is the second one. I'm sorry. It needs to be fixed. All right, let's fix it back. Okay, my hand must have been on this desk. Weird. That's a lot closer. Okay, now, final answer. I'm going to do it in green. I'm going to go up here to the top. It's going to open up like this. Something along those lines. This is going to open up down here. This one's going to open up. And hopefully, hopefully, you weren't surprised by this. Boy, that one's really lame, so I got to be nice to you if that happens to you, huh? But you're not trying to draw it on a tablet, and I totally missed the one right there. One thing I'm going to mention, wow, this should really come out this way, all the way to that asymptote. One thing that I am going to mention here is my domain and range change. So just so you know, right here, it doesn't talk about it, but the range would be negative infinity until it gets to, hold your hat, let's see, 1, 2, 3. -3, union with, oh, and includes -3, union with, how high do we go? We're at 1 to infinity. So that's a little bit weird. I just wanted to point that out, that it changes, and it's because of this amplitude, okay? All right, last one. So you can see this as quickly as I can get it done. Okay, this one is way spread out, not making me happy. So change to 1/4 y equals 1/4 sine 2x plus 3. No, I'm not changing anything else. A is 1/4. I'm definitely going to change my scale on this. Ooh, and it's got a +3. Oh, that 1/4, that is not nice. Here, sad face. Okay, B is 2. The period is 2 pi over 2, which is pi. And C, thankfully, is not there. And D is 3, so Y equals 3. I'm going to climb, you know what? I'm going to make this line Y equals 3. And I'm going to put down here, I'm going to make this the x-axis. This is x. This is y. It will just give me a lot more room to make this 1/4. So if this is 1, 2, 3, 1/4 is like down 1/4, up 1/4. That's like 3.25. That is just, that's why I said sad face 2.75 here. And those are my asymptotes. Wow, they're not equal. Sad face. There, this one's a little better. Okay, you get the idea. Graph paper, baby. We need more graph paper. Okay, so now that I've got those labeled, as nice as it is not, 0 to pi is going to be a full, wow. So if pi is here, this is pi over 2, this is pi over 4, and 3 pi over 4. So this is a full period. So I'm going to go back and do one full period this way. And I'm not going beyond that. I'm doing sine, so I'm starting here. Now, I'm shortcutting. This is positive, so I know it's going to go up, down, down, up. So, and then this was going backwards. It's going down, up, up, and it would say down, down, and keep going. So I'm going to use my yellow. I'm going to do a highlighter to say this is, well, I'm missing it. There we go. I'm trying to hurry because you guys don't want to watch me forever. I'm not offended. It's okay. So everywhere this was crossing the midline. I'm looking for those midline points. Oh, would you look at that? We didn't have a shift and it was on top of the y-axis. Again, no shock, no all. What we expected. All right, so here's my graph. Okay, the difference in these graphs on this one with this tiny little thing is that they're closer together with the tiny little amplitude. It doesn't make the graphs any harder to do except for the first one. It just wasn't nice. But again, I'm looking to see those values are crazy with 1/4, but you're welcome to fill in all of this that you may need. I did it, and that's it. We're done. Have a nice day.